And now please welcome the CEO of Applied Micro, Paramesh Gopi.
Good morning, and it's a pleasure to be here. And in the light of what Jay just showed and all of the other neat things that have been talked about this morning, I'd like to give you an update on the history of ARM in the data center. So about 3 years ago, we broke ground, and we did something fairly adventurous. We decided that we would take really brawny cores, custom cores, with a very, very extensive scalable fabric and some really neat I/O technology that was part of our base business, and build Xgene. So today, I'm really, really excited to say that, first, if you were to go back and look at all of the pieces that we put together, we're in a really neat place. Xgene has arrived in servers. So before I go any further, I just wanted to make sure that I put up something that my lawyers always tell me to do, which is to say that nothing I'm about to tell you construes future guidance in terms of revenue for a company like ours. So I'll get the official stuff out of the way and go to the technology pieces really quickly here. So about 3 years ago, we started this. Last year, Frank held off a 64-bit ARM board, group hug board. I actually have it today, right here. It's fully functional, the world's only first ARM 64-bit group hug device, fully functional, and we did something really neat over the last year. We took something that people thought could never be done and have brought it to a point where we have major customers like Hewlett-Packard, please go look at their booth, building really, really neat microserver and cloud-scale servers, now running enterprise applications. So major, major, major update from last year. We've taken a category from, I would say, concept to reality. In the last 6 months, we've got Red Hat, Canonical, and Oracle for Java announcing full support for Xgene on the ecosystem front. And again, shows you that we've taken a really bold 18-month step ahead to really look at how we scale Xgene going forward. We didn't stop with Xgene 1, and I really wanted to kind of take this opportunity to tell you that the next Xgene is due to sample this spring. So just to keep cadence in mind, again, 2011, when ARM announced the existence of an architecture, we announced a product roadmap. Today, we've delivered a complete first-generation device, and you can go and experience it at our customers. You can see it on the Group Hug platform with a complete 64-bit software ecosystem. Today, I'm very pleased to announce that we will be sampling our next generation of Xgene, and once again, we've taken the next big step forward. We have included RDMA, which is native to InfiniBand, and have integrated the RDMA functionality to run over 10 and 100 gig Ethernet with the next generation Xgene. So if you really think about it, we've taken brawny ARM cores, fabric, and a completely extensible scale-out system and put it on one device. And this is going to enable us to do something really neat. We're now going to show you, and I'll show you through this presentation, how we're going to take and scale out a whole bunch of the ARM 64-bit brawny core technology to really deal with a rack-scale computing problem, which is what the next-generation enterprise and cloud data centers are looking for. So if I were to start off and look at, Xgene and our companion product, Xweave. Xweave is the connectivity piece that lets you take lots of Xgenes and hook them up together to really build really massive, dense rack-scale systems. So if you were to look at today, you see pretty much an example of a sled and a server node sled concept, where you have a whole bunch of Xgenes, and you have them connected, like you showed, in either with multiple Xgene cards in a sled or in a tray connected to essentially a load balancer or to a top-of-the-rack switch, where you essentially have traffic coming in and out of the server-dense system. So what would we do? Well, we decided that we needed to take Xgene blades and make them sled scale. So we want to make sure that we connect a whole bunch of Xgene chips together seamlessly so that you would have lots and lots of brawny cores big memory access, and make sure that they can all be connected with standard 10 and 100 gig Ethernet. So if you were to just look at why is this important, well, if you look at an application like Memcached, Memcached requires you to be able to support massive amounts of memory access with local context per core. So if you were to look at it and see, how do we scale a Memcached system out? For instance, how can I give you 2x the density or 3x the density at the same or much lower TCO than what you would have with a conventional non-scale-out system? Well, I'm very, very, very excited to tell you that today, with Xgene 2 and Xgene 1, and our really neat Xweave product, and Xweave represents all of the effort that our company has put into building 100 gig carrier class routing technology and communications technology, long haul and short haul. It brings all of that communication technologies into the rack. So just think about this. If you were to go buy a Cisco router, a Huawei box, or a ZTE box that usually hooks up data centers together, and if you were to take the same fiber optic and digital signal processing technology, and instead of connecting 2 data centers across an ocean, you connect a bunch of clusters within a large data room. That's what we are about to do with Xgene 2. So if you were to really look at what we've done and what we will do this next year, with all of the work that has happened thus far, we're going to bring Brawny cores, a fabric, and RDMA with the complete set of connectivity, whether it's copper, optics, or any combination of the above, to change the effective density that a scale-out application can have. And an example that I've shown here is basically that you can take a current 1x memcache type rack and scale it to 3x between Xgene 2 and Xweave. So once again, we started off 3 years ago. We decided that we would bring ARM to the data center by combining disruptive I/O, big memory, Brawny cores, full enterprise class Brawny cores with everything that you'd come to expect from a software enterprise readiness perspective. And here we are, and we want to show you that with Xgene 2, you can take all of that and scale it out to hundreds of cores within a rack, completely connected, seamlessly, low latency, across multiple sleds. And then I wanted to give you a peek as to what we're going to do next. So we're not stopping, we're essentially continuing the pace of innovation, moving things forward. So if you were to really look at where our heads are at and what we've seen from our initial customer base adoptions and from the feedback that we've gotten from the community, well, the first and foremost is enhancements to accommodate cloud workloads, whether it's accelerators, whether it's sub-packet processors, whether it's networking functions that need to be integrated. We're going to put all of that on the next generation of Xgene. Now combine that with FinFET. So our teams are now working on how do we take FinFET and apply it to this problem to give you more cores. So we have 8 cores on a die today, going to 16 plus cores at the FinFET generation for our next generation, and 240 gigs of I/O that you can essentially use Rocky to connect. So again, we're leveraging all of the InfiniBand RDMA technology to make sure that we can connect 4x the density of what we have today for our next generation, which is Xgene 3. And guess what? With FinFET and the communications I/O being integrated into one monolithic piece of silicon, we see a huge difference to the TCO. So just to recap, we're going to have 2 generations of ARM in the data center by the end of the year. All of our customers, you can go experience platforms today, have enterprise-class applications running on Xgene. With Xgene 2, we're really excited because we can now really scale out to hundreds of cores within a sled, moving on to hundreds and maybe even thousands of cores within a rack. And we're right on our way to develop Xgene 3 to make sure that we capture all of the requirements that the community needs to build really massive private clouds and public clouds. Thanks very much, and please experience Xgene in the lobby.